Today is, in fact, today is January 8th, 2021, and Happy New Year, everyone. Welcome to the monthly Longhorn community meeting. So today there are just a few things we want to cover. As you know, we have successfully shipped Longhorn 1.1 release last December, and so far things looks good. And let's show what we have right now regarding the 1.1. Yeah, based on our public metrics, I think about a quarter of our users already upgraded successfully to the 1.1 release, and our total node number on worldwide now is crossing like 18,000, which is pretty good. And I think the number itself has been increased by like 3 to 4-fold over the past year. And the team is working hard to keep up with everybody's questions and via Slack or GitHub. And you can see that, in fact, all the questions you have asked, we have answered, and we're trying to help the community to get better hang of the Longhorn. So that's the one goal of this meeting as well, to help you to know better what is happening on the Longhorn community and on the Longhorn development. So there are a few things I want to talk about today. So since the 1.1 release, we have introduced a few changes. One thing might be notable to you is we still deploy the Longhorn default storage class, but in the past, we suggest you not to modify it because the upgrade process of Helm do have a problem that if he detect the resources, they cannot like modify it on the fly, that they will fail the whole upgrade process. So that is the last thing we want to see. So for the 1.1 release, there's a user visible changes. Once you install the Longhorn, and you can see that I have Longhorn installed here. And in fact, from the resource and the config map, we are going to install something called the Longhorn storage class config map. So this config map, in fact, is just a YAML file, storage class.yaml, and we just put the information here. So this is the value of this file. The value of this config map defines what we define the Longhorn storage class as a default storage class in your cluster. So you can see here we have a storage class and Longhorn and annotation. If you don't want storage like Longhorn storage class to become your default storage class, you can remove this line. And also, you can modify in here, you can modify whatever parameters you want. You can add your recurring job, you can add your disk task selection, you can change the number of replicas. And this, whatever changes here, as long as if you save it, the Longhorn will automatically recreate the default storage class for you. So now you can still use this, use the default storage class and without worrying, and have a way to modify it without worrying it will cause trouble in your upgrade. So we can take a look at what do we have on the storage class, which this is the real storage class we're using. And you can see that, in fact, I should need to, is that way to view this as YAML? No, okay. But we can see that it wasn't set as default now, and I can click on set as default to it. I think if I do that, it will not going to take effect. Okay. Yeah, probably the refresh period. Let's check about that later. So let's go back to the config map, and we can try to update the number of replicas for example, 4, and I'm going to save it. And now you can see that, okay, so the storage class Longhorn has been updated. It's now no longer default. And when you click into that, the number of replicas is 4. So there were some questions after 1.1 release, and when users say they delete the default storage class or change anything about default storage class, nothing take effect. That's because this config map mechanism we put in there and to help you to modify this storage class. And the real reason behind it is because the parameter side, the parameter section of that storage class can now be modified. So this is the way we created to help you on working on that. So this is the one user visible change. Another one is we have improved the failure recovery model in Longhorn, as you can see, in fact, here. Yeah, I haven't got anything running on here, but you can see that we have a few mechanisms to help you with the failure when something happened unexpectedly, like your node down or your engine crash due to, for example, lack of bandwidth or CPU pressure. So now we automatically delete the workload pod, and if the volume has attached unexpectedly. And that means that if you have a situation like, for example, you have your Docker or containerd daemon on a node that crashed, or the Longhorn engine crashed due to lost connection to all the replicas, this option we are all going to automatically recover your workload as along with your volume. Previously, we have another mechanism just do the read attach of the volume and then remount to the container. But because the mount mechanism in the Kubernetes workload pod is like one way, it's not bidirectional. So whatever we mounted on the node is not going to be reflected inside the workload pod. And also that mechanism doesn't apply, only apply to the ext4, and also doesn't work for the subdirectory if you are using subpath feature of the Longhorn of the Kubernetes volumes. So now we decided that in fact it's better for us to safely delete workload pod if the workload pod only have this Longhorn volume available. And that's going to be automatically trigger the Kubernetes to redeploy this pod and also reattach and go through the proper process to set this volume up again. Another thing we have added is we add this pod deletion policy. We note this down. So for the production environment, we do recommend to set this to delete both stateful set and deployment pod if this happens. So the reason is, in fact, it's a little bit complicated. You can see the details in the Longhorn. I think there's one section, recovery volume on the unexpected detach, not this one, the one before. Okay, node failure handling on the Longhorn side. So here we have a detailed explanation and what to expect when the node failure happens and how the Longhorn deletion policy have an effect on that. So just short story, if you want to have your stateful set and deployment pod automatically recovered after if the net node goes down, and make sure that if the Kubernetes move the pod to another node, the Longhorn volume can go with it. Choose this section, choose this option to delete both stateful set deployment pods to make the recovery faster. Yeah. All right, but in fact, there's sadly upstream. So recently we received a report that it doesn't work in certain environments, and sadly we found there's an issue with upstream Kubernetes for the more recent Kubernetes release. So I think it happens on the Kubernetes 1.19 plus because so the issue itself is Kubernetes didn't add certain tent to the node as what they did before, and the bug was created as was reported to the upstream Kubernetes community, and there are people like working actively on that. This is just basically there's a tent not executable that wasn't set by the Kubernetes, so that means it's going to the Longhorn sorry. The pod cannot be evicted from the Kubernetes node. That's also basically blocking everything else in the following process. So I think there's a PR right now, and the upstream committee is working on merging this, but still haven't. Yeah, so you see the last update is like 16 hours ago. So we will expect this fix to be included in the next minor release of the 1.19 and the 1.20. So if you're using the version below 1.19, everything should still work fine. All right. So that's for the currently known issues and some usability change, some user experience change on the storage class side. So what we have next is the next release we're going to have is 1.1, as you can see here. From the 1.1 release, we already have the scheduled work, and still our engineer on the team is active working on that. So there are a few highlighted items in the 1.1 release, 1.1.1 release. So a few things. There are users asking to run in Longhorn workload on dedicated nodes, and that's the reason is sometimes they have other mechanism to limit the stateful workload running on certain nodes. That means that then Longhorn doesn't need to be running on the nodes that not going to have a stateful workload. So currently, we don't encourage user to do that, but if you have a very large cluster, you might really have a way to separate it. So we are considering that adding this feature, but not probably natively, but provide a way for the user to use node selector and others to make sure that Longhorn runs on that and still work fine without like having the Longhorn manager and the Longhorn instance manager running on every node. The next thing we are working on is we have this idea of how can we self-diagnose for the replica engine disconnection. In fact, recently we have put in a knowledge-based article to explain to you what happens, why sometimes the replica disconnection or the engine will go crash, and you can check it out here. There are a few reasons. Most likely the reason, not sure why it wasn't published yet. Okay, yeah, so that article hasn't passed the final review yet. Yeah, so they will be there very soon. But most likely the reason to have engine or replica disconnected is either because of the engine and replica process getting CPU starving, or you have network issues. And also, if you are using very slow disk like a spinning disk, that might have some issues when Longhorn try to write the data to the disk and the disk cannot respond fast enough. Right. So, but for those scenarios, for what the user see is almost the same, like disconnect from the replicas or and those similar logs. So we're thinking if it is possible for us to provide more guide on the, say, if the user like overutilizing the CPU or it's because of network. So this is in fact, it's a pretty technical hard thing to do, but we are going to investigate it, spend some time and see what we can get to like that. For example, if there's something like network interruption happens, it's better if the Longhorn can just show that, for example, from UI or even in the log, say that this situation happens, it's very likely you have unstable network. And so this kind of information should help user to pinpoint what is wrong. All right. So also there are a few things. So like next thing I'm talking about here is as you know, Longhorn is replicated synchronously, and every replica contains the same data as the volume. This request has put in for a while. Currently, we have a manual way to restore a single replica from the volume. But in the case that you have a big system, you have a bunch of like Longhorn volumes on different disks, this one was going to take a while. So we want to build a tool to help user to scan your disk and find the Longhorn volumes and recover from that. So this is more like a tool, the improvement tool we want to work on. Also, this new CSI FS group policy has been introduced in the Kubernetes 1.20. And this one is very interesting because we have one issues before, which our users experience very long attach time. And the reason is the Kubernetes FS group change is basically an own operation. So if you are using something like S3, using Minion and have a lot of file in your volumes, and you want to like change the file group, change the FS group for every file on this volume, it's going to take a very, very long time. We saw in some of our users cases, it can take hours and to get it sorted out. And that is just Kubernetes doing the work and change the FS group. So in the 1.20, there's one new feature from CSI part and allow us to mount to change a different approach of deal with the file permissions and inside volume. And for example, we should able to do a mount with a different file permissions. And this is the one thing we want to improve. If you are using in the 1.20, this one feature should like greatly speed up your volume attach time if you have a lot of file and want to change the file permissions inside inside your volume. So a few other things we've been working on. So upgrade the Longhorn engine automatically. Previously, as you know that now every time we upgrade the Longhorn, you are on the Rancher or you are using Helm chart or using YAML, you only upgrade the Longhorn manager for the first part. And later you have to go there manually to upgrade the Longhorn engines. It was designed in this way that because we want to make sure that if there's something wrong with the engine upgrade process, you do have a way to, for example, you have the backup and then you can roll back and you can basically you can do that at your leisure time. But sometimes in fact, if we put this in the whole automation framework, it will take some extra API calls to make sure every engine has been upgraded correctly. And also, if anything error happens and it's not really that clear that user knows what to do. So we decided that it's probably better in the future. We can build this logic inside the Longhorn itself to upgrade the Longhorn engine automatically once a new version of the engine was detected. This is going to take some time. And the first version will come out with 1.1.1 is most likely going to be experimental and not going to be enabled by default. And when it's getting mature and getting more stable, we can enable it and make sure that it's a more reliable and easy way for the user to upgrade Longhorn engines. The other two features we are working on is the live migration support for KubeVirt and the backing image feature in Longhorn. Both of them, in fact, is related to another project we've been working on called the Harvester. So the Harvester is a habit converged computing infrastructure, and that's Harvest converged infrastructure software as you can see, whatever what's Nutanix or VMware offered. So the Longhorn is playing and the critical role of the providing storage there. So those two features we are working on them to provide the support better for the Harvester, and also it can be used with any other VM-based storage because you can see live migration and the base image, right? So those are the features we've been working on right now for the next release, and we haven't set a timeline for the 1.1 yet. Most likely we will be there in a couple months. All right, so that is all for the Longhorn update side. Any questions?
Not really. I mean, I had one situation, I think, when I first upgraded Longhorn from 1.0 to 1.1 using kubectl, and then I was just trying to do this using Helm chart. It didn't quite work, but the idea, should it work at all if I first updated from kubectl and then try to upgrade Helm chart?
Yeah, so is the Longhorn just originally installed from kubectl or installed from Helm
No,
chart?
from Helm chart,
Yeah, it's better if you keep it consistent, because kubectl when you don't upgrade it from Helm cannot remember its version has been upgraded, so it might got confused.
Okay.
Yeah. So it's better if you install from Helm and just upgrade from Helm, and if you install from using YAML, just stick with it.
Okay, sure. Thanks. That's it.
All right. All right. Thanks everyone for joining, and we'll send out a recording later. And have a good day.